Alright, in this video we're going to solve some quadratic equations, or at least attempt to solve some quadratics with a TI83 or TI84, and I'm going to discuss the advantages and disadvantages. An advantage right off the bat, it's a quick technique using the graphing calculator. Look at this first example right here. Before I grab the calculator, I'm just going to go ahead and factor this just to show you that you could solve it this way. X minus 7, x plus 2. We're just factoring that. Notice negative 7 times 2 is negative 14, and negative 7 plus 2 is that negative 5. So we set each factor equal to 0. X minus 7 equals 0. Therefore, our answer here will be x equals 7. And our other one setting this factor equal to 0, we get x equals negative 2. Now, I'm going to go ahead and go to the calculator, and I'm going to show you these same two answers, and I'm going to show you two ways by graphing. Alright, the first way is using what's called the zero, I guess calculating the zero on the calculator, but on the TI84 I'm going to go to y equals, and I'm going to type in just the left hand side. We have 0 on the other side, so I'm going to go to y equals and I'm going to type in x squared minus 5x minus 14. And just make sure on a standard graph we can zoom 6 for a standard screen. And notice we have a curve. It swoops down, it swoops back up, and we're interested in where the x values right here, where this curve crosses the x-axis. So one way to do that is to go to second and then press trace, and you want to find the 0. And the reason why we want to find the 0 is because the function is equal to 0 right here. So press enter. And now let's find this one right here. Eyeballing that, it looks like it's going to be somewhere around negative 2, and that's exactly what we have here. But it's asking for a left bound. So there's two ways you can do this. You can physically scroll using the left and right arrows with your cursor, and you want this flashing cursor to be to the left of where this intersection is, or this 0. So anywhere in here is to the left. I'm going to press enter. Notice it says right bound now. So we can go to the right side using the right arrow. And there we are. That's to the right of where it crosses right there. So we'll press enter. And then we press enter one more time when it says guess. And as you can see, one of our answers is negative 2. Notice the y value 0. Well, that's what the function was equal to over here. Now let me show you another way without scrolling with the cursor. I'm going to find this same one again, but showing you a different technique. Going to second trace. I'm going to go to 0 again. But instead of scrolling like I was doing here, scrolling back and forth, if you can't find that cursor, because sometimes it can be hard to find, you could use these coordinates down here to find it, or you could just type in a value that's to the left of that. Like we said, that was negative 2. Type in any number that's to the left of negative 2, such as negative 3, negative 4, negative 5, and so forth. Negative 5, that's definitely to the left. Now type in a right bound, something to the right of negative 2, such as negative 1 or 0 or 1, anything like that. I'm going to type in 0 since that's definitely to the right of where it crosses. I'm going to press enter and enter one more time, and notice you get the same answer. I like that technique a lot better versus scrolling for my left and right bound, because sometimes you can lose that little flashing cursor. So let's go ahead and find this one over here. It should be 7, and we're just going to double check. So second trace, go to 0. And now we want something that's to the left of where it crosses right here, because we're way over here now. So either you can use the scrolling arrows and come over here, or you can just type in something to the left of this number, such as 1, 2, 3, 4, 5, 6, any of those numbers. Let's type in 6 for a left bound. And now type in a right bound, anything to the right, such as 8, 9, or 10. I'm going to type in 10. And then press enter one more time on guess. And notice our other solution, 7. Notice the y value again is 0 because that's what the function's value was equal to. So that's one way to do it. Now let me show you a second way of finding those two answers. Now this works for any equation as long as your answers are real. I'll explain more about that in a second. So I'm going to come down here to y2, and I'm going to put in the right hand side of the equation. So we have the left hand side, I typed it in y1, We had the right hand side, I typed it in Y2. Now what I'm going to do here is I'm going to make this line bold so you can still see it graph. I think that's going to, let me see. I think that's going to make it bold. We'll see what happens. I want you to see the two graphs. We're going to see this first one again, but where y equals 0, the x-axis, that's where y is equal to 0. And let's graph this and see what happens. Look, there you go. That line that just came across the screen right there, notice it's bold. And what we just did there is we typed in two equations. Now, instead of us finding the 0, we want to see where these two expressions intersect. So back here on the graph, again, you did see where it did get bold. Let's find where they cross. They cross here and here. But now to find it using this technique, you press second trace and you want to find the intersection. Now I like this technique good as well, I like this technique just fine as well. Now it's asking you different questions. First curve. And I'm scrolling around. Oh, there's my cursor. So suppose that cursor is hard to find. You know, I don't see it right now. The reason why you do not see it right now is because the cursor's at the point 0, -14. That is way down here. Notice if I press left, it's going to start to pop back up. There it is. If you ever lose track of it, this will tell you right around where that cursor is. -1.5, -4 roughly. Now, that's the first curve. I'm going to move it somewhere close to where this bold line and this curve intersect, such as right there. And now all you have to do is press enter 1, 2, 3 times, and look, there's one of your answers, -2, 0. Alright, so again, we're showing you the same answer right here. Let's go to second trace again. Let's go to intersect. And now let's find this one over here. Now, you can move along this curve using left or right. But now if you press up or down, it will jump between the curves. I'm going to press up and notice it's going to jump to that bold line. And now I can move along this bold line pretty quickly. So I'm moving on along over here to the other intersection. Now, as I'm doing this, if I wanted to jump to the second curve, I could press up again. Oh, the cursor's gone. It's at 5, -11. So that's way down here somewhere. So I can scroll to the right and there it is again. So remember, left and right will scroll on the curve that you're on. Pressing up or down jumps back and forth between the two curves. Remember that. But anyway, there's that intersection. Press enter, 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 and there's our other solution, 7, 0. So that's how you find the solutions of quadratics, and quite frankly, it works for any equation as long as your answers are real. Now let's go ahead and do this second equation. Now, I'm going to show you a disadvantage now. The advantage right now is that it's fast, but the disadvantage is about to pop out at us with this example. So I'm going to go to y equals, I'm going to type in that left-hand side, 9, and we got to use x squared instead of the n. So we're going to do 9x squared plus 4x and minus 16. And I'm going to use the intersect technique. We type in the left-hand side, we type in the right-hand side, we can press graph. Now our graph's going to look new. There's our first curve, and notice the line. Here comes the bold line. There it is. So that first funky curve, that was y1. The second bold line, that was y2, and that's nothing but the x-axis. So we can find the intersection. Let's press second trace. Let's go to intersect. And oh, where's my cursor? It's at 0, -16, so it's way down here somewhere. So what we can do, and let me get this back up here since I've got the equation typed in. What we can do, instead of scrolling along this curve, we can press up and watch what happens. It jumps up to this second equation, this y equals 0. So let's find this solution over here. So I'm close to it. I'm going to press enter, enter, enter. And here is a disadvantage. This is an approximation. That is a rounded answer. Now I'm going to tell you what, I'll just copy it over. There's one of them. And let's go ahead and find the second one while we're at it. So we'll go to second trace. Let's do the intersect since we have two equations typed in, or two expressions. I'm going to press up to get onto this flat curve, and I'm going to move to the right over here to close to that second intersection. Press enter, enter, enter. And look, there is another weird looking answer. That is an approximation. So that is a disadvantage. The reason why that's a disadvantage is because if I were asking for exact solutions, these two answers right here are not exact. So this is a disadvantage. And I'll tell you what, I'm going to put these right here. And we'll see how they're still correct, but they're rounded. So how would we get exact solutions of this equation? What we'd have to do is we'd have to do the quadratic formula, or we'd have to complete the square. I'll tell you what I'm going to do for this one. I'm going to do the quadratic formula to get some exact solutions. It never hurts to review that. You can fast forward through this part if you're pretty comfortable with quadratic formula, but I want to show you that we do get these same two answers either way. So it's set up nicely for the quadratic formula. A is equal to 9, B is equal to 4, and C is equal to negative 16. And I'm going to move through this pretty quick. We're trying to find what n is equal to. We already got our two answers right here. But n is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Therefore, we plug everything in. So negative b, that's going to be negative 4, plus or minus the square root of b squared. So we take b and square it, that's going to be 16, minus 4 times 9 times c, that's our c value there, negative 16. And this is all over 2 times 9, 2 times a, using the quadratic formula. So here, let's simplify this down. We got negative 4 plus or minus the square root. So computing everything inside of that square root, 16 minus 4 times 9 times negative 16, we get 592 inside of there. And this is all over 18. Now this 592, I'm pretty sure that will break down some. So let's use our prime factorization to break up 592. If we take 592 and we divide it by 4, we get 148. Just breaking it up into its prime factors. 4 breaks up into 2 times 2. 148, let's see, can we divide that by, no, 148 divided by, what, let's do 4. 4 should go into it. So we get 4 and 37. 4 times 37 is 148, and then 2 times 2 gives you 4. And this is as far as it'll break down. 2, a 2, another 2, another 2, and 37. 37 is a prime number. So every time we have a pair, when we take square roots, I'm going to write it down one time. So there's a pair and there's a pair. So what this really simplifies to give us is 4 square root of 37. Now I'm still going to copy over everything else. This negative 4 here and all over 18. Now again, I pulled out a pair of 2's there and a pair of 2's there. Every time you put or circle a pair, you write it down one time. So 2 times 2, that's how I got that 4 right there. And then the 37 was left over. Now we can go one more step to totally simplify this. Since all these pieces here, here, and here, they're all even, we can divide everything by 2. So we have negative 2 plus or minus 2 square root of 37, and this entire thing can be over 9. Now this is our exact solution. And I tell you what, let me go back up here and grab both of these. These two pieces that we have here are approximations. But what I want to do is I want to pull the calculator back up, and I want to show you that this will give us these, except this is exact, this is approximate. Again, that's a disadvantage to graphing. Graphing will not give you that nice answer. It'll only give you an approximation. So let me slide these over here so we can get the calculator up. So typing that in, how in the world do we type that in? I'm going to type in the entire numerator, and I'm going to focus only on the plus for right now. So I have negative 2 plus 2 times the square root of 37. I don't need that parentheses there. And then we can divide that all by 9. That's what the quadratic formula means. You take it all over 9. And look at that answer. 1.129502785. This is still approximate, but notice it matches that right there. There's that answer right there. So again, a disadvantage to graphing. You get an approximate, whereas this is exact. And let me show you the other one, the negative 2 minus 2 square root of 37. I'm going to press enter, and then I'm going to divide it by 9. There is our other one, negative 1.573947. Can't quite see that because of the light, but notice that is that right there. So that is one disadvantage to graphing. Now, let me show you another disadvantage to graphing. And that's going to be with this example right here. Let me come to a new page. All right, so looking at this real quick, you might think, oh, it factors. Nope, it doesn't factor. So you might say, okay, I'm going to try to graph it. But here's a disadvantage. Watch what happens with this problem. All right, so I'm going to go to y equals. No matter how we try to do this, we're going to have a problem. I'm going to leave the 0 there because that is the right-hand side of the equation, and I'm going to type in the left-hand side, x squared plus 2x plus 9. And now, again, what we're going to do is we're going to see this graph come up, and we're going to see this bold line on the x-axis because we've used that quite a few times now, but there's going to be a problem. There's the first curve way up there. Here's our bold line. That's a problem. They do not intersect. So what in the world? How do we solve this? You might say there's no solution. There is a solution, but the solution is not real. This is going to be one of those imaginary solutions. We're going to have an eye flying around on this thing. So there's only two ways that we can really solve this thing. You can either complete the square or you can do the quadratic formula. And while I'm at it, what I'll do is I'll go ahead and show you both techniques. I mean, you're getting all this stuff at one time anyway, so it's worth showing it to you. Let's solve this using the quadratic formula first. A is equal to 1, understood 1 there. B is equal to 2, and C is equal to 9. Quadratic formula, we're going to have n is equal to negative b, so that's negative 2, plus or minus the square root of b squared, that's going to be 4, because 2 squared is 4, minus 4 times a times c, all over 2a, which is going to be 2 times 1. And let's keep on working with this. So we have negative 2 plus or minus the square root. This is 4 minus 36. Bam! There's your imaginary number getting ready to show up. 4 minus 36, that's negative 32. And this is all over 2. See that? Remember, when you take the square root of a negative number, you do get an imaginary answer. So that's why we did not have a solution that we could work with on the calculator screen when we graphed. Again, another disadvantage. But we can go a little bit further with this too. We can break up that 32. 32 is going to be 8 times 4. 8 breaks up into 2 times 2 times 2. And 4 breaks up into 2 times 2. So breaking up the square root of negative 32, we have a pair of 2's and another pair of 2's. So writing this answer out, we have negative 2 plus or minus. Pull out one pair of 2's and another pair of 2's, therefore we get 4, and then we have an I. Remember, when you take the square root of a negative number, it's automatically we're going to pull that I out. Don't forget that. And then we have the square root of what left over? We had that 2 left over right there. And this is all divided by 2. Now we can simplify this one step further. We can divide this by 2, this by 2, and this by 2. You never divide anything on the inside of the house by something that's not inside of a house. Got to look back at your properties of radicals. And if you forgot about this ideal, look back at your section on complex numbers. Check out those videos. But dividing this by 2, this by 2, and this by 2, we get negative 1 plus or minus 2i square root of 2. And you can put all over 1 if you want, but please don't. Just leave it like this, because we can always put over 1, and that's what we'd get down there. So that is our exact solution. So again, that was a problem, because when we looked at it on the calculator screen, those two curves did not cross. And the reason why is because this answer is imaginary. Now, if you're watching this video, you're probably wondering, or you're probably still a little confused about completing the square. So this is a good time to show you completing the square as well. We're going to get this same answer, and I'll tell you what, I'm going to copy this over one more time, and we're going to complete the square on this. This is not a bad example to complete the square on. Everything's set up nice, except remember we have to do move our constant term, the number without a variable, we move it over here. So we have n squared plus 2n. And remember, when I complete the square, I put plus a blank is equal to, if you move this 9 over here, that's really what you're doing is subtracting 9 from both sides. So we have negative 9 over here, and remember, when I complete the square, I plus a blank. So take this number right here in front of n, which is 2. Every time you divide this by 2, that gives us 1, and then we need to square it to put it back up here. Well, 1 squared is 1. So we added 1 to this side, we got to add 1 to this side. Now, over here, if you want to factor this, that'll be just fine. This one's not a nasty piece to factor. It's going to be n plus 1 squared. And the reason why it's n plus 1 squared is because if you 1 times 1 gives you 1, 1 plus 1 gives you 2. But remember in class, I've always told you to remember that number, and that will always be that piece right there. Alright, so moving on, this is equal to negative 9 plus 1, that's negative 8. I just combined those together to get that right there. Let's take the square root of both sides to solve this quadratic. So taking the square root of both sides, we have n plus 1 over here. And this is equal to, there's your I again. Taking the square root of a negative number, we do have an I that we pull out. And if you take 8 and break it up, that's going to be 2 times 2 times 2. So we can pull out a pair of 2's. So we have plus or minus, don't forget the plus or minus either. We have that pair of 2's that we circle, so we have 2. I'm going to write my I back down, and then we have square root of what left over? We have a 2. And now all we have is one more step. Let's subtract 1 from both sides. So therefore we have n is equal to, you cannot combine this stuff. The only thing we can do is write negative 1 plus or minus 2i square root of 2. Does that look familiar? It should, because it is the exact same answer that we got back here by doing the quadratic formula. So, showing you the calculator techniques in class probably got your hopes up, and it's good. I mean, it does work, but I've showed you some disadvantages as well. One disadvantage being sometimes the two curves will never cross each other. And that's automatic. That's automatically got to tell you that your answers are not real. The answers will be imaginary. And then the other disadvantage was this one back here when we worked it all out and we got an exact solution, whereas the calculator will only give you decimal approximations. But it still has it's still quick, and it's still worth checking. And it's how you can get real good at this stuff. You can do all this pencil and paper work, and you can use the calculator to check your answer using the graphing techniques I've showed you here. There's tons of other ways to do these things on the calculator too, but I'm going to take it step by step with you. These are the ones I've showed you in class so far, and that is it for this video. Hope it helped.